Hello and welcome back to the Python learning series. Now that we know a couple data types, we can learn more about how to use them. In this session, we're going to be talking about typecasting. What is it? How do we do it? And why is it important? We'll tackle these and more, so buckle up. Before we start, here are some more small tips and bits of knowledge. First, let's talk about constants. These are any values we do not intend to change for the duration that our program runs. Think, for example, if we wanted to use the value of pi, which never changes. We just initialize it like this. We name constants with all caps like this, so it's easier to tell these values are constants. Now we can call pi every time, and we know that this value should not change. Next, when we initialize number elements which are comma separated, or in other words, big numbers in the thousands or millions, we can separate the zeros by adding underscores like so. This is interpreted as separators for easier readability, as commas are not allowed. This does not affect the code at all. Now we see it's easier to tell this number is 10 million. And let's talk about comments. We know each line of our code is executed by the program from the top to bottom. But sometimes, especially if there are complicated code written and we want to put a small piece of info for context, we put in what we call comments. To do this, we put a hash sign at the beginning of the line we want to turn into comments. See here how when I've turned a line to print out something into a comment, the compiler knows to ignore this action, as it is only intended for clarity when reading the code. We can put as many comments as we'd like, but the best practice is to make our code be readable on its own, without the need for comments. Alright, now on to the main topic. What is typecasting? This is when we convert a data type to another data type. It's done for multiple reasons that we will find out later. First, let's take a look at this example. Here we have an age variable that is an integer and a message variable that is a string. If I want to combine them together in one print function, the integer needs to be converted to its string equivalent, like so. We usually do this by combining them with a plus sign. This is called concatenation. Now it prints the message correctly. This is the first type of typecasting. It's called explicit typecasting. This means we explicitly wrote in our program that we want the age variable to be typecasted into a string type variable before combining it with the message variable. There's another way to do it. In this example, we just tell Python we want these variables to be printed, and the compiler figures it out on its own how best to print the variables. We can see the age variable is still typecasted in the print function. It's just now we didn't have to explicitly tell Python to do so. This is called implicit typecasting. Notice how Python even adds a space in between the variables. We just tackled explicit and implicit typecasting of the integer data type to string. What if we convert the message variable into an int data type? First, let's confirm the type of our message variable. We do this by calling the type function like this and putting the variable in. It returns the string data type, which is what we expected. Let's convert it explicitly to integer by using the int function. It returns an error. Why? Because it does not know how to typecast a string of characters into its equivalent integer data type. But if we have, for example, a string that has an equivalent value to an integer like this, 42, we now know that it will only typecast successfully if the conversion would make sense. There are more. Let's take a look at typecasting the Boolean data type. If we try to typecast a number type to Boolean true or false, we get true every time except for the value 0. If we try to typecast a string type, we get true every time except for when the value is an empty string. Conversely, if we try to typecast the Boolean type to an integer, we get 1 for true and 0 for false. And if we try to typecast the Boolean type to an integer, we get the string equivalent of the words true and false. There is a function to explicitly typecast values in all the data types. Some of them are listed here below. Try it yourself and see the results. Alright, let's recap. Typecasting is the conversion of a data type to another data type. Usually, it is done to keep consistency. We can do it either explicitly or implicitly, and both have their advantages and disadvantages. Now armed with this knowledge, you're ready to use it on your code. If you learned something, please like this video, write on the comments, and subscribe for more Python content coming your way. Until then,